All right, here's another free fall problem where I have a bridge, let's say. I'm throwing a baseball off the bridge. The difference is I'm not just dropping it, I'm actively throwing it downward at 20 meters per second. So again, I always like to make my VI positive if possible. Last time it was 0, so it wasn't positive or negative. But I'm going to call VI positive 20 meters per second. And what we have to consider is how is gravity going to affect this baseball? So gravity is going to pull the baseball downward and cause it to accelerate more. And so in that case, because it's in the same direction, we're going to say that the acceleration is positive 10 meters per second. Whereas if it were in the opposite direction, if the ball were being thrown up, we would probably want to say the acceleration is negative. But because it's in the same direction the ball's going, we're going to say it's positive. We know the time is 2 seconds. So this is all the information we're initially given. So the question is, how far will it fall in 2 seconds? So how far is the work of delta x? That's what we're looking for. The quickest way to get it is to use this equation here. So I will plug in delta x equals VI times t, so 20 times 2, plus 1/2 a times t squared. And so 20 times 2 is 40. And then 1/2 times 10 times 2 squared is 4, times 10 is 40. This is 20. So I get delta x equals 60 meters. And at this point, I'm actually done. How far does it fall? It would write it falls 60 meters. So again, I want to actually take a moment and actually write out an answer, not just rely on the chart. But how could I do this with the chart? What could I do? So I could continue this and say, all right, well, what is the final speed of the ball? So every second, it's going to accelerate by 10 meters per second. So in your head, you could, kind of do a chart where it's like, right now it's going 20. So 1 second later, it's going 30 and then 40. Or you could use this equation, VF equals VI plus AT. So VF equals VI 20 plus A times T. Bottom line is you get the final speed is 40. If I want, I can find the change in velocity. 40 minus 20 is 20. I don't really need to. But the average of 20 and 40 is 30. So on average, you're going 30 meters per second, and you do that for 2 seconds. So if I use this last equation, and I plug in 30 for V average, and delta x is unknown, and t is 2, if I solve for delta x, I also get 60. So it's another way to do the problem. Again, this is probably easier just to plug into this, but if you prefer the other method, you can do that. So bottom line, the baseball will fall 60 meters. Its change in position, its change from here to where we take a snapshot of it is 60 meters, and so it has fallen 60 meters in 2 seconds. And that is it. So until next time, I am Derek Genova. Have a delightful day.